Hello everyone. I am Mrs. D. Shanti Chellaya, working as assistant professor in EC department. Now I am going to take few nonlinear applications of op-amp under open loop mode, that is comparator, schematic trigger and peak detector. Application of comparator, schematic trigger, peak detector and precision rectifier. Why it is called as nonlinear application? Because the output doesn't have any relationship with the input. Hence, it is called as nonlinear application. Comparator, schematic trigger, peak detector, and precision rectifier are few circuits which use op-amp and along with other passive components. Now we will discuss the principle of operation of the op-amp comparator. It is used as a comparator and it leverages the device extremely high open loop gain to determine which of the two input voltages is larger or lesser. In this configuration, the op-amp operates without negative feedback, causing the output to quickly saturate to either the positive or negative supply voltage. No feedback is used in basic comparator. The output saturates to plus Vsat or minus Vsat of the power supply voltage. The main application in the op-amp comparator is zero crossing detectors and level detectors. If V plus is greater than V minus, output is plus Vsat. V plus and V minus are the two input voltages given to the inverting and non-inverting terminal. If V plus is less than V minus, output is minus Vsat. The switching between plus Vsat and minus Vsat is very fast due to the high gain capacity of the op-amp. The comparator mode is of two types. One is the non-inverting configuration and another one inverting configuration. In non-inverting configuration, the Vin is applied to non-inverting terminal, that is plus, and V reference is given to inverting terminal, which is minus of the op-amp. Then V outside, which is plus Vsat, when V input greater than V reference. It is given in the diagram as shown in the slide. V reference is equal given to minus and Vi is given to plus, and V out is taken from the output of the op-amp. So when you observe the waveform, input is a sine wave. When input is greater than the V reference, then output is plus Vsat. When input is less than V reference, output is negative, that is minus Vsat. Thus, alternatively, it switches between plus Vsat and minus Vsat, thus generating a square wave form. In an inverting configuration, Vin is applied to inverting terminal and V to non-inverting terminal. V out is high when Vin is less than V reference. So when it is plus Vsat, it is positive supply. When it is minus Vsat, it is in negative supply voltage. The main applications of this comparator are: it is used in threshold detector, zero crossing detectors, oscillator circuit, and low battery warnings. The applications of comparator are given as threshold detection, zero crossing detector, oscillator circuit, and low battery warning. So the main specific application is zero crossing detector, which is nothing but it is used to detect when the input voltage crosses the zero level. So in this zero crossing detector, it is a basic comparator where V reference is set to 0 volt, detecting every time the AC signal changes its polarity. So when the input signal is greater than the 0 volt, it is minus Vsat, and when the input signal less than 0 volt, it is plus Vsat, indicating the time at which it crosses the 0 level. Thus, this configuration will act as zero crossing detector. The next application of the comparator is the Schmitt trigger. It is a regenerative comparator with positive feedback. It provides hysteresis and it improves noise immunity. The Schmitt trigger adds positive feedback to create two separable threshold levels, upper and lower trip points. This prevents the output from chattering or oscillating when a noisy input signal is near the reference voltage. The output switches only when the input signal crosses the threshold level. It prevents false triggering due to noise. The input is applied to the inverting terminal of the op-amp. When the input exceeds the upper trip point, the output goes low. The circuit operates with an upper threshold UTP and lower threshold LTP. When Vin rises above the UTP, the output switches to negative saturation, which is shown in the hysteresis loop in the graph. And when the Vin falls below the LTP, at which point the output switches back to plus Vsat. So the output does not switch back until the input crosses the LTP. Here, in the figure shown in the circuit diagram, input is given to inverting terminal and portion of the output voltage is fed back to the non-inverting terminal, which is set as the V reference voltage. So VUTP is given as R1 by R1 plus 2 R2 into plus Vsat, and VLTP is given as R1 by R1 plus R2 into minus Vsat. So the hysteresis is given as VUTP plus V minus VLTP, which defines the hysteresis width, which is the noise immunity of the circuit, that is any noise with peak to peak amplitude less than Vh will be ignored. It is commonly used to convert sine wave to irregular sine wave to square wave. Sine wave, not only sine wave, but also any irregular signal can be converted to a regular square wave. Now we will discuss the operation of peak detector. It is a circuit that captures the maximum voltage value of the input signal and maintains that value on the capacitor until it is reset. It uses op-amp, diode and capacitor as shown in the circuit diagram. So input is given to non-inverting terminal and output is fed back to inverting terminal, thus acting as a voltage follower. A diode is connected at the output of the op-amp and a capacitor is connected at the output to the ground level. Using op-amp instead of a simple diode capacitor circuit improves the accuracy by eliminating minus 6 volt diode forward voltage drop. So now how it works? The circuit operates by combining the properties of voltage follower with the storage element capacitor. When the input voltage Vin is higher than the voltage that is currently stored in the capacitor, then output is positive, making the diode forward biased, and it allows the capacitor to charge until Vc equals to the peak of Vin. When the input signal drops below the peak, the op-amp output swings low, hence it reverse bias the diode and it disconnects the capacitor from the op-amp, thus allowing it to hold the peak voltage value. To measure a new lower peak, the capacitor must be discharged. This is typically done using a manual switch or MOSFET switch connected in parallel with the capacitor. So when you see the output response of the circuit between the time and the V out, the input signal is given with different peak. Every time it marks the peak of the input voltage. But when the peak voltage is less than the peak voltage which has been detected earlier, it will miss the peaks. Hence, to overcome this limitation, we have to use a high switching MOSFET, which should be connected in parallel with the capacitor. Higher precision designs may include a second diode in the feedback loop to prevent the first op-amp from saturating negatively, which speeds up the recovery time for detecting the subsequent peaks without missing any peak. Now we will discuss the operation of the precision rectifier. Precision rectifier, it is also called as super diode. It is an operational amplifier circuit that acts like an ideal diode by compensating for the standard diode's forward voltage drop, typically 0.7 volt for silicon. This allows the circuit to accurately rectify very small AC signals even in the order of millivolt or microvolt range where a conventional diode would fail to conduct. Conventional diode will rectify voltage only when it crosses zero point 0.7 volt, whereas the application where you need to rectify voltages below zero point 0.7 volt, this op-amp with diode, which is also called as precision diode or rectifier, can be used. During positive half cycle, it acts as a voltage follower, hence the output follows the input. During negative half cycle, output is zero. Accurate rectification will happen even for small signals. The op the op-amp's high loop gain causes its output to jump to the diode's threshold voltage almost very instantly when the input signal turns positive, which effectively cancels the drop in voltage. So when the input is a sine wave, then output is follows the input only during positive half cycle, and during negative half cycle output is zero. Thus output produces similar to a half wave rectifier. Thank you.